Hello everyone. So let's continue KCET 2017 Solutions Physics. I am Satish T S, lecturer in physics, Gurukula Institute, Sirsi. Let's discuss 15th problem. It says that a basic communication system consists of a simple question. So obviously communication system starts with information source. After it will transfer the signal through transmitter. After it transfers through channel, after it is received by the receiver, and finally it moves to user of information. So B, D, B, A, D, E and C, this order must be the right answer. 16th problem. A galvanometer of resistance 50 ohm is connected to a battery of 3 volt along with a resistance of 2950 ohm in series, shows full scale deflection of 30 divisions. The additional series resistance required to reduce the deflection to 20 divisions is. Here the students will get confused how to take the divisions. The divisions is nothing but the deflection of the pointer to a corresponding value of current. So take it as current itself, no problem. So if I use the voltmeter formula, that is what I is equal to V divided by R plus RG. Suppose if I use that formula, so I'll get 330 is equal to 3 divided by 50 plus 2950. This is the equation number 1. In the second equation, current I must be equal to 20 divisions. 20 is equal to 3 divided by 50. 50 is the galvanometer resistance, that would be the same, and R is the series resistance that has to be connected with the voltmeter. So if I divide two equations, equation number 1 and equation number 2, I left with 3 by 2 is equal to 1 by 3000 into 50 plus R. So therefore I will get R as 4450 ohm must be the answer. But here they have not given 4450, instead of they have given 4440. So nearest answer is 4440, we can say. 17th one, let's discuss the 17th question. The 17th question is, which of the following semiconducting devices is used as voltage regulator? For that, it's a direct question. Zener diode will be used as the voltage regulator. 18th question. A straight wire of length 50 cm carrying a current of 2.5 ampere is suspended in mid-air by a uniform magnetic field of 0.5 Tesla. As shown in the figure, the mass of the wire is, and they have given the acceleration due to gravity is 10 meter per second square. Obviously we know that F is equal to mg, and we know that the force due to the magnetic field is F is equal to Bill here, Bill sin theta, but the magnetic field is perpendicular to the current carrying conductor, so obviously sin theta becomes 1 here. Suppose if I equate both the two and I am making them equal, mg is equal to BIL, so therefore mass m must be equal to Bill divided by g. So suppose if I substitute the values properly, I will get 62.5 grams. That is the answer for that. Fourth one, the working of the magnetic braking of trains is based on, this is the application of linear eddy current, so therefore eddy current is the answer for that. The next question is very good question. In an AC circuit shown, keeping K pressed, if an iron rod is inserted into the coil, the bulb in the circuit is. See, suppose if we insert the coil inside the inductor, its inductance increases, so therefore current through the bulb will decreases, so that decreases the brightness of the bulb, so obviously brightness decreases is the answer. Next question, 6th question. A bar magnet is allowed to fall vertically through a copper coil placed in a horizontal plane. The magnet falls with a net acceleration. Okay, here this question is based on Lenz's law here. So once it comes near to the coil, it produces the current, right? Obviously, according to Lenz's law, it produces the current. And obviously, the north pole opposes the north pole. So obviously, what will happen? Its acceleration obviously decreases. So therefore, we can say that G is less than actually the actual. So obviously, less than G is the answer for that. Yeah. Next question, 7th one. The value of the acceleration due to gravity at a depth of 1600 km is equal to. So for this we have formula that G bar is equal to G. I mean new acceleration due to gravitation is equal to acceleration due to gravitation into 1 minus D divided by R, where D is the distance and R is the radius of the earth. Suppose if I substitute the values as G, D and R, I will left with 7.35 in meter per second square. That is the answer for that. Next question. The next question is 8th question. Two balls are thrown simultaneously in air. The acceleration of the center of mass of the two balls when in air is that xm, center of mass, is equal to m1 v1 plus m2 v2 divided by m1 plus m2. So here they have given that two balls are thrown simultaneously in air, correct? So obviously simultaneously in the sense they must be traveling with the same acceleration. So obviously v1 is equal to v2 is equal to g. So obviously suppose if I take g outside, so obviously inside m1 and m2 will be there, so divided by m1 plus m2. So m1 plus m2, m1 plus m2 cancels each other. We left with 19th problem. So 19th problem says that according to the Huygens principle, during the refraction of light from air to a denser medium. So obviously you have studied the Huygens principle of refraction. Obviously both wavelength as well as speed of the refracted ray decreases. So therefore wavelength and speed decreases must be the answer for that. 20th question. The energy gap in case of which of the following is less than 3 electron volt? See, the options given is aluminum, iron, germanium and copper. So here aluminum, iron and copper are the conductors. So obviously their energy gap must be always greater, correct? So obviously the energy gap must be the minimum, that is only for the germanium, that is what? Conductor. That is what? Semiconductor. So obviously germanium is the answer for that. 21st question. The particles emitted in the decay of uranium 238 to 92 to 232 uranium 92 is a simple question here. Obviously you know that in a decaying the uranium converted into thorium, right? This is what 234 to 90 by emitting one alpha particle. Obviously again thorium will be converted into what? Actually uranium again by 234 uranium 92. So that is by emitting 2 beta particles. So obviously one alpha particle and 2 beta particle must be emitted in the decay of 238 uranium 92 to 234 uranium 92. So obviously 1 alpha and 2 beta must be the answer for that. 22nd question. 2 point charges A is equal to plus 3 nanocoulomb and B is equal to plus 1 nanocoulomb are placed 5 centimeter apart in air. The work done in moving the charge B towards A by 1 centimeter is. We know that the work done is nothing but potential difference between, I mean to say that the voltage potential difference between the 2 points multiplied by the charge Q. So that will give the work done. So here you can calculate easily the potential difference, right? That is V is equal to 1 divided by 4 pi epsilon naught times 1 divided by 4 pi epsilon naught times Q1 into 1 by R1 minus 1 by R2. We have 1 by R1 is equal to 1 by 4 and 1 by R2 is equal to 1 by 5. So obviously get the value of VA minus VB. So multiply that by the charge Q, that is what? 3 nanocoulomb. You will get 1.3 into 35 into 10 to the power of minus 7 joules as a work done. Yeah. Next problem, 23rd one. A particle is dropped from the height h. The de Broglie's wavelength of the particle depends on. We know that velocity of the particle is equal to square root of 2 times gh, and the de Broglie's wavelength lambda is equal to h divided by mv. Suppose if I substitute the value of v here, lambda is equal to h divided by m into square root of 2 gh. So obviously lambda is directly proportional to h to the power of minus 1 by 2. So that must be the answer for 23rd question, h to the power of minus 1 by 2. Next really good question. We have the value of I in the figure shown in the figure is. So this is based on the Kirchhoff's current law. See, they have given 20 ampere current is flowing here and 5 ampere current is leaving the junction. So obviously at this point this must be the 15 ampere current must be flowing. So on the other hand 4 ampere current is entering this junction, and here it must be 19 ampere current must be leaving the junction. Exactly right. So on the other hand 3 ampere is leaving the junction and 5 ampere current is joining the junction. Obviously the leaving junction is 2 ampere current. So here I must be equal to 19 plus 2 because 19 and 2 are incoming currents. So obviously 21 ampere must be the answer for that. So 10th question is, if vector E and vector B represent electric and magnetic field vectors of an electromagnetic wave, the direction of propagation of the wave is along. Obviously we know that the property of the EM waves, that is what E and B are always perpendicular to one another. So obviously they must travel in the direction of E cross B. That is the answer for that. Go for the next question, that is what 11th one. A system of two capacitors of capacitance 2 microfarad and 4 microfarad is connected in series across a potential difference of 6 volt. The electric charge and energy stored in the system is an easy problem. So try to find out what is the equivalent capacitance of 2 microfarad and 4 microfarad. So that will give you the result of 2 into 4 divided by 2 plus 4. So that will give you the value of 4 by 3 microfarad. So that 4 by 3 microfarad which is connected to the battery of 6 volt. So please take next problem. The waves set up in the closed pipe are. So obviously this is a general question. We can say that it is longitudinal and stationary. So it is always longitudinal and stationary. Okay, let's take 25th question. In the figure shown, if the diode is forward voltage drop is 0.2 volts, the voltage difference between A and B is. Obviously, they have given the capacitor here. It is of no use because the another end is not connected to anything, so no current flows through the capacitor. So we can say that the voltage drop across the diode is, they have given it is 0.2 volt. So the voltage drop across the 5 kilo ohm resistor is, that is 1 volt, and voltage drop across 5 kilo ohm, another 5 kilo ohm is also 1 volt. So obviously by applying the Kirchhoff's voltage law across the given circuit, I will get VAB is equal to 1 plus 0.2 plus 1, that is what 2.2 volts. So that must be the answer for 25th question, that is what 2.2 volt. 26th question, for which combination of the working temperatures the efficiency of Carnot's engine is least? So we know that the efficiency can be calculated by using 1 minus T1 divided by T2 into 100%. So for this question, trial and error method is the best method. Suppose if you substitute the first option, that is what 80 Kelvin and 60 Kelvin, so eta will become 1 minus 60 divided by 80. So at that time you will get around 25%. Suppose if you put 100 Kelvin and 80 Kelvin as T2 and T1 respectively, at that time you will get 1 by 5, that is what 20%, that is what the least. So that pair will be the best suitable for the efficiency of Carnot's engine, which is the least one. Okay, so therefore 180 must be the answer for that. Let's take the next. The charge flowing in the circuit, that is Q is equal to C into V. So that will give you the value of 4 by 3 micro into 6. So that will give you the value of 8 micro coulomb as the charge flowing in the circuit. Similarly, if you want to find out the energy stored in the capacitor, energy stored is equal to half CV square. So obviously half into C value we know 4 by 3 and V square is, that is what 6 to the power of 2. So obviously the answer must be 24 microjoules is the answer. Let's go for the 12th question. So it says that out of the following graphs, one that correctly represents IV characteristic of ohmic device. So ohmic device in the sense they are always linear in nature. So only one graph which is linear through the origin. So therefore this graph is the right answer for that question. Go for 13th question. Young's modulus is defined as the ratio. It's a direct question. We can define Young's modulus as stress divided by strain. So obviously we can say it is tensile stress divided by, this is what, longitudinal strain. This is what longitudinal strain. So this is the answer for that. And 14th question, the scientist who is credited with the discovery of nucleus in an atom is, really direct question, it is a Rutherford is the answer for that. Please keep on watching the next video to get the solutions of others as well. Thank you. So 27th question says that it is a general question. of dual nature and dual radiation of matter and radiations. So in that, from the following graph of the photocurrent against the collector plate potential for two different intensities of light, I1 and I2, one can conclude that this is the actual general graph actually. So intensity of I3 is greater than I1, 2 is greater than I1, but here they have given only two plots, so because of that we can say that I2 is greater than I1. 28th question. Hydraulic lift works on the basis of Pascal's law, a general question. It's a Pascal law. It works on the basis of Pascal theory or Pascal's law, we can say. 29th one. A cylindrical conductor of diameter 0.1 millimeter carries a current of 90 milliampere. The current density is. So usually we know that current density J is equal to I divided by A, correct? So I is given as 19 to 10 to the power of minus, that is 90 milliampere. But 3 into pi r square. So pi r square we need to take. So this is what pi is 3, nearly taken as 3, and r square they have given the diameter as 0.1, so obviously it is 0.1 millimeter divided by 2, because we have to get the radius. So because area of cross section is pi r square, so don't take the cylinder area, that is what outer surface, that is what 2 pi rh. We are not expecting that. We are just wanted the cross sectional area of the cylinder, that is what pi r square itself. Suppose if you substitute the values properly, you will get 1.2 into 10 to the power of 7 ampere per meter square. That must be the answer for that. 30th question. In Young's double slit experiment, if yellow light is replaced by blue light, the interference fringes become. Obviously the lambda of yellow light is greater than blue light, so obviously lambda decreases here. Once the lambda decreases, theta decreases. So once the theta decreases, obviously fringes become very narrower, so therefore narrower is the answer for that. Keep on watching the next video for next questions. Thank you very much. Question number 31. According to the Cartesian sign convention in array optics, so for that, according to the sign conventions, all the distances in the direction of incident ray are taken positive. That must be the answer. Question number 32. A linear object of height 10 cm is kept in front of a concave mirror of radius of curvature 15 cm at a distance of 10 cm. The image formed is. Very good problem. See here, they have given height of the object is given as 10 cm and radius of curvature is 15 cm and object distance is 10 cm. So obviously we have relationship that f is equal to r by 2, so therefore it is 15 by 2 centimeters. According to the mirror equation, that is what 1 by u plus 1 by v is equal to 1 by f. So 1 by minus 10 because u is negative here, and plus 1 by v is equal to 1 divided by minus 15 by 2 because the radius of curvature is negative, hence the focal length is also negative. So here we get v is equal to minus 30 centimeter. So obviously it is an virtual image, so we can say that it is virtual image. So here we can find out the magnification by using the magnification formula. Hi divided by ho is equal to minus v by u, what we have. So finally we get the magnification as minus 3. So here by which we can find out height of the image is equal to minus 30 centimeter. So obviously the image is magnified and it is inverted because it is negative sign is there. So obviously it's a magnified image because it is the height of the image is greater than height of the object, so obviously it is magnified and it is inverted. So which of the following logic gates is considered as universal? Correct? Sorry, so before that we have 33rd question. The magnetic field at the center of the current carrying loop of radius 0.1 meter is 5 times that at a point along its axis. The distance of this point from the center of the loop is. So we have a relationship that the magnetic field at the center to the magnetic field at axis is equal to 1 plus x square divided by r square whole to the power of 3 by 2. They have given the condition that B center, I mean magnetic field at the center is equal to 5 times the axis magnetic field. So suppose if I make them, or if I substitute the value of B center in this equation in this equation, I left with 5 root 5 is equal to 1 plus x square divided by 0.1 whole square whole to the power of 3 by 2. So squaring on both sides, so that what will happen, 3 by 2 multiplied by 2. So obviously 2 get cancels here, 2 get cancels. So finally we left with 25 into 5 is equal to 1 plus x square divided by 0.1 whole square whole to the power of 3. So finally cubing, take cube root on both sides, we left with x square is equal to 0.04 and hence x is equal to 0.2 meter. That must be the problem answer for that. 34th question, which of the following logic gates is considered as universal? We have universal gates as NAND gate and NOR gates. So out of the given options, they have given the NAND gate, so that must be the universal gate. 35th question, a motor pump lifts 6 tons of the water from a well of depth of 25 meter to the first floor of the height of 35 meter from the ground floor in 20 minutes. The power of the pump in kilowatt is, and they have given the condition G is equal to 10 meter per second square. We know that power is equal to work divided by time, so therefore work is equal to mgh. So this is also one of the formula we have in work, power and energy. So finally power must be equal to mgh divided by t. Suppose if we substitute the values accordingly, you will get it is 3000 watt or 3 kilowatt. That must be the answer for that. Please try to take the next question, that is what 36th question. 36th question says us that, so this is what they have given. So here 36th question is little bit confusable actually. So that they have given that plus 2q charge and minus 4q charge. When we placed at the corners of the equilateral triangle, they never form electric dipoles. So therefore we have doubt in solving that particular problem. So let's wait and try to discuss that later. And here we have 37th question. So here we have 37th question, that is what the power dissipated in 3 ohm resistance in the following circuit is. It's really a lengthy problem they have given here. Here you need to assign the branch currents, okay, or define the currents in all the branches, and after that apply the KVL to get the current flowing through the resistor 3 ohm. Okay, so once you get 3 ohm resistor as 1.75 ohm, so once you apply Kirchhoff's voltage law, you will definitely get the value for current I, which is flowing through the resistor 3 ohm. So that is what 1.75 ampere. Okay, so after that we have formula that P is equal to VI. I replace V divide V as I by R, so that we will get I square divided by R. So that will give you the value of 1.01 watt, or that is nearly equal to 1 watt as the answer. That is what 38th question. In a nuclear reactor, the function of the moderator is to decrease, it is nothing but speed of the neutrons. It is nothing but speed of the neutrons. I hope you have studied the theory of the moderator in the nuclear reactor. Okay, so the next question is 39th question. 4 into 10 to the power of 10 electrons are removed from a neutral metal sphere of diameter 20 centimeter placed in air. The magnitude of the electric field at a distance 20 centimeter from its center is. Very good problem. Suppose if we have removed 4 into 10 to the power of 10 electrons, after that the remaining charge Q will be given by Q is equal to N into E. So this N is 4 into 10 to the power of 10 and charge on the electron is 1.6 into 10 to the power of minus 19 coulomb. So obviously we left with 6.4 into 10 to the power of minus 9 coulomb. Okay, we have formula that E is equal to 1 divided by 4 pi epsilon naught times Q divided by R square. Here Q is 6.4 into 10 to the power of minus 9 and 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. But you have to be careful while taking the R value, that is what the distance from the center they have given, right? So obviously distance from the center is 20 centimeter, but as you already know that at the center electric field is always 0, so obviously we have to measure the electric field from the surface of the sphere, therefore it will be always 10 centimeter. So obviously here you are getting 5760 Newton per coulomb as the answer. Please try to take the next question. So that is what the output of a step down transformer is measured to be 48 volt when connected to a 12 watt bulb. The value of peak current is simple question. We know that power P is equal to V into I is equal to P by V. Substitute the values. That is what 12 divided by 48. That will give the value of 1 by 4 ampere. Try to take the next question, 41st question. So according to that, the mass defect of helium is 0.03 U. That is what atomic mass unit. The binding energy per nucleon of helium in mega electron volt is. So we know that binding energy formula is delta M into 931 divided by A, and they have given that the atomic mass is how much? It is 4 is given, and they have given defect. Mass of defect is 0.03. This they have given directly. So therefore binding energy, suppose if I substitute the values accordingly, I will get 6.9825 mega electron volt. That is the answer. Please try to take the next question, 42nd question. The angle between the velocity and acceleration of a particle describe the uniform circular motion. A direct question, it is 90 degree. 43rd question. During the scattering of light, the amount of scattering is inversely proportional to fourth power of the wavelength of the light, because intensity is directly proportional to 1 divided by lambda to the power of 4. 44th question. The susceptibility of a ferromagnetic substance is, as we discussed, susceptibility for the ferromagnetic substance is always high, and it is 2 greater than 1, we can say. Please take 45th question. A proton, a deuteron and an alpha particle are projected perpendicular to the direction of the uniform magnetic field with the same kinetic energy. The ratio of the radii of circular paths is described by them is. This is really a good question, we can say. So here we can easily solve this problem. We know that the radius of the nucleus is equal to square root of 2 mk divided by qb. So obviously r is directly proportional to square root of mass divided by charge, right? So we know that mass of the proton is m and the charge on the proton is q. Then on the deuteron, its mass is 2 times the mass of the proton, that is what 2m, and the charge on the deuteron is as it is in the proton, so obviously it is q again. Suppose if we take the alpha particle, the mass of the alpha particle is 4 times the mass of the proton, and charge of the alpha particle is 2 times the charge of the proton. So therefore, suppose if I substitute and make them the ratio, so I will left with rp, I mean radius of the proton, radius of the deuteron, and radius of the alpha particle as 1 is to square root of 2 is to square root of 2. That is the answer. Let's take 46th question. Actually 46th question is, a metallic dipole of magnetic moment 6 into 10 to the power of minus 2 ampere meter square and moment of inertia of 12 into 10 to the power of minus 6 kg meter square performs oscillations in a magnetic field of 2 into 10 to the power of minus 2 Tesla. The time taken by the dipole to complete 20 oscillations is, and they have given that take pi is nearly equal to 3. So here we need to use 2 pi into square root of 1 divided by PE, but we are not getting the exact answer for that. So let me try to solve this problem as soon as possible. Okay, so let's take the next question, that is what 47th question. 47th question. So the velocity of a car is moving with a velocity of 20 meter per second is stopped in a direction of 40 distance of 40 meter. If the same car is traveling at double the velocity, the distance traveled by it for the same retardation is. So here we can easily find out what is the value of acceleration, correct? It is what the retardation, I mean negative of the acceleration is what retardation here. So we have v square is equal to u square plus 2as, initial velocity obviously 0, so 20 square is equal to 22 into a into 40. So here we are getting a is equal to 4 meter per second square. So suppose if I use the same formula again, that is s is equal to v square divided by 2a. Here v is doubled, it means that 20 plus 20, right, or 2 into 20, that is what 1600 divided by 2 into 5. Okay, so I will get as displacement, I mean that is a distance traveled when the velocity is doubled, that is 160 meter. Let's take 48th question. So if a vector A is equal to 2 I cap plus 3 j cap plus 8 k cap is perpendicular to the vector B is equal to 4 j cap minus 4 I cap plus alpha k cap, then the value of alpha is, see, both the vectors are perpendicular to one another, so therefore their dot product must be always equal to 0. So I am just multiplying 2 into I into minus 4 into I, that is what we are getting, minus 8 over there, and 3j and 4j, obviously they will get plus 12, and 8k into alpha, that is what, plus 8 alpha. So obviously if we simplify, I will get alpha is equal to minus 1 by 2. Let's take 49th question. If the SI unit of the specific heat capacity is, a direct question, this is what, joule per kg Kelvin, or it is joule per kg per Kelvin, that is the answer. Okay, 50th one, let's take next question. So according to 50th question, a piece of copper is to be shaped into a conducting wire of maximum resistance. The suitable length and diameter are dash and dash respectively. Okay, so we know that resistance is equal to the resistivity into length of the conductor divided by area of the conductor. So we know that area is equal to pi r square, we can write that. Okay, so into the shape of conducting wire of the maximum resistance. So at that time, suppose if there is a diameter, it must be in the circular path, so that's why I'm taking the pi area as pi r square. Okay, so to increase the resistance, there must be increase in the length of the wire, so L must be increased, and denominator area pi d square, so d must be decreased. Out of the given options, 2L and d by 2 are satisfying this answer, so obviously they are the answer for that. 51st question, 51. A substance of mass 49.53 gram occupies 1.5 centimeter cube of volume. The density of the substance with correct number of significant figures is, and here we know that density is nothing but mass divided by volume, right? So and the volume has significant figure of 2. So out of the given options, 3.3 has significant figure of 2. So obviously C must be the answer for that. Okay, this is a significant figure of 2. Okay, 52nd question. So in 3 parts of a transistor, emitter is of, it is, you as you know, the emitter part is moderately doped, and it is heavily doped with the moderate size, because heavily doped because it has to emit the electrons from it. So obviously it is moderately doped and moderate in size, and it is heavily doped. Okay, next 53rd question. Two spheres of electric charges plus 2 nanocoulomb and minus 8 nanocoulomb are placed at a distance d apart. If they are allowed to touch each other, what is the new distance between them to get a repulsive force of same magnitude as before? Very good question. So before touching the two charges, the distance between them is d. So here we'll get F is equal to 1 by 4 pi epsilon, that is what K here is equal to 2 into 8 into 10 to the power of minus 18, in the sense nano, 10 to the power of minus 9, 10 to the power of minus 9 will become minus 18 divided by d square. Okay, once they are touched, obviously there must be the flow of charge carriers from higher potential to lower potential, that is from minus 8 to plus 2. So how much charge is transferring is nothing but x is equal to minus 5 nanocoulomb is transferring from higher potential to lower potential. So on A, I mean at point A is nothing but 3 nanocoulomb. On the opposite side it is minus, in both sides it is minus 3 as well as minus 3. So at that time the new force of repulsion, which must be equal to constant K into 3 into 3 into 10 to the power of minus 18 divided by d1 square. So if I make the comparison between equation number 1 and 2, I'm just dividing them. 1 by 2 is equal to, or you can make them equal because the force must be of the same magnitude. So I left with 16 divided by d square is equal to 9 by d1 square. So finally I am getting d1 as 3 by 4 d. That must be the answer. Let's take 54th question. The minimum value of effective capacitance that can be obtained by combining three capacitors of capacitance 1 picofarad, 2 picofarad and 4 picofarad. So obviously out of the given options, 4 by 7 picofarad is the smaller capacitance value, and we will get 4 by 7 by connecting all the three capacitors in series. Here I have solved that problem. You can easily find out the effective capacitance when the capacitances are connected in parallel. Okay, 55th question. The energy in electron volt required to excite an electron from n is equal to 2 to n is equal to 4 state in hydrogen atom is, we know that energy required is equal to 13.6 divided by square of the state. Here we have to excite an electron from n is equal to 2 to 4. Therefore E2 minus E4 is equal to 16 divided by 2 square, that is what, 4, minus 13.6 divided by 4 square, that is what, 16. If you solve that problem properly, you will get 2.55 electron volt. That is what 56th question. So this is what two simple pendulums A and B are made to oscillate simultaneously, and it is found that A completes 10 oscillations in 20 seconds and B completes 8 oscillations in 10 seconds. The ratio of lengths of A and B is, so actually we have to use here t is equal to 2 pi into root L by G, so that time period is directly proportional to square root of the length actually. But if I solve that problem, I'm not getting the proper answer for that. So let me check and I'll try to give you the solutions as soon as possible. Okay, please take 57th question. 57th question. In a system of two crossed polarizers, it is found that the intensity of light from the second polarizer is half from that of the first polarizer. The angle between their path axis is, this is the problem on Malus law. We know that I is equal to I naught cos square theta. I is the finally polarized one, that is, as we know, this must be half of the unpolarized light. So that is what I naught divided by 2, what the condition they have given here. We can substitute I naught divided by 2 is equal to I naught cos square theta. So obviously cos theta is equal to 1 by root 2, because I naught cancels each other. So theta is equal to 45 degree. Okay, 58th question. Which of the following properties is false for bar magnet? It does not produce magnetic field. Option A itself is a wrong option, because all the magnets, they must produce magnetic field. 59th problem. A coil of inductive reactance 1 root 3 ohm and the resistance 1 ohm is connected to a 200 volt 50 hertz AC supply. The time lag between the maximum voltage and current is. So this is the problem on RL circuit. Suppose if I use the formula properly, still the answer is mismatched actually. So let me try to give the answer for 59th problem as soon as possible. Okay, let's take 60th problem. In meter bridge experiment with a standard resistance in the right gap and a resistance coil dipped in water in the left gap, the balance length obtained is L. If the temperature of the water is increased, the new balancing length is, obviously if the temperature is increased, the resistance increases, so therefore the length must be decreased because it has to increase the resistance value. So new length must be less than the actual length. Okay, so thank you for watching this video. Please try to share this video. We have left with around 4 problems. I will try to give the solutions for 4 problems as soon as possible. Okay, so I am Satish here from Gurukula Institute, which is located at Sirsi. I am lecturer in physics here. Okay, we are offering the courses for IIT G Mains, NEET, as well as KCET and other competitive examinations. Okay, suppose if you are interested, please try to visit us or contact us. Okay, so thank you very much. Good luck. Wish you all the best.